So, if you've seen the show The Last of Us, I'm guessing you've had that same chilling thought I did. Could a zombie fungus actually happen? Well, the truth is, as it so often is, way stranger and honestly more fascinating than fiction. Today, we're going to peel back the horror and look at the mind-bending reality of nature's puppeteers.
Now that's not a line from some horror movie. That's from a scientist, David Hughes, and it just perfectly nails the sheer weirdness of what we're talking about. It's a complete takeover, where the host is nothing more than a vehicle, a puppet for the fungus. Okay, let's really get into this.
Okay, so let's set the record straight. The real deal versus its Hollywood counterpart. In the show, you've got the terrifying bite. In reality, the Ophiocordyceps fungus spreads through microscopic spores, just floating in the air. And that whole hive mind thing? Nope, pure fiction. Each infected insect is on its own grim, solo journey. And the transformation? It's not some fast, violent explosion. It's a slow, creepy, methodical takeover that can stretch out for up to 10 days.
So what does this slow, methodical takeover actually look like? Let's get into the nitty-gritty, the fascinatingly macabre life cycle of the classic zombie ant fungus. It all kicks off with a single, invisible spore landing on an ant. It drills right through the exoskeleton and starts to multiply inside, carefully eating non-essential bits first to keep the ant walking. Then, the real manipulation begins. The fungus makes the ant leave its home and just climb. It's not random, it's being driven towards a high, humid spot that's perfect for the fungus. Then comes the final act, the death grip. The ant is forced to bite down on a leaf with a force it literally can't release. And finally, with the ant dead, the fungus sends a stalk erupting from its head to rain down a new generation of spores on the colony below. Horrifying.
And you know, this strategy, as horrifying as it is, it's so effective it actually has a name: summit disease. It's a well-known trick used by all sorts of parasites. The goal is always the same: get your host as high as possible before it dies. It's all about getting the best possible launch pad to spread your kids.
So this is the big question, right? How in the world does a fungus pull this off? How does it actually seize the controls and drive the ant to its own doom? Well, the mechanism is even more incredible than you're probably thinking.
You know, for the longest time, everyone, scientists included, just assumed the fungus went straight for the brain. I mean, it makes sense, right? But recent research revealed a massive twist. The fungus, it pretty much leaves the brain alone. It doesn't even need it. So instead of a brain invasion, the fungus creates this vast, interconnected network of cells all throughout the ant's body, literally wrapping itself around the muscle fibers. This network basically acts as an external brain pulling the strings on the muscles. It hijacks the ant's internal body clock to control when it moves, and then targets very specific neurons to trigger that final fatal climb. All the while, the ant's actual brain is left intact, essentially a prisoner watching its own body betray it.
And get this isn't some new, freaky thing. These zombie makers have been around for millions of years. And trust me, ants are not their only victims, not by a long shot.
Take fruit flies, for example. They get infected by a fungus that forces them to climb up high, glue their mouths down, and then lift their wings to give the fungus a perfect, clear shot for dispersal. Then you've got trapdoor spiders in Brazil, infected by a brand new species that erupts right through the spider's own trapdoor. And even in British caves, there's a fungus, actually named after Sir David Attenborough, that forces spiders to abandon their webs and die out on exposed walls. It's happening everywhere.
And the timeline for this is it's staggering. Hard to even wrap your head around. The oldest direct proof we have is 99 million years old, a fungus erupting from an insect, perfectly preserved in amber from the time of the dinosaurs. The first scientific write-up came in 1859. And even today, we're still constantly finding new species, which just shows you how ancient and successful this strategy really is.
But, you know, nature loves a good plot twist. This fungus might seem all-powerful, but it doesn't have the whole forest to itself. There's a counterattack.
I mean, it seems like the ultimate parasite, doesn't it? Once an ant's infected, it's game over. It's a guaranteed death sentence. But what about for the fungus itself? Is it really that successful?
Okay, this is where it gets really wild. When you look at the actual numbers, whoa, check that out. Only about 6.5% of these spore-producing stalks are actually viable. The vast majority, over 93%, are neutralized before they can ever infect another ant. So, how is that even possible? because the parasite has its own parasite. Yeah, you read that right. There's another fungus called a hyperparasite that specifically hunts and attacks the zombie fungus. It basically castrates the stock, stopping it in its tracks and preventing it from ever developing or releasing its spores. It's this microscopic war that actually helps keep entire ant colonies from being totally wiped out.
So all of this brings us right back to where we started, to that one question that, let's be honest, has been in the back of your mind this whole time. Should we be worried?
All right, let's break it down. The good news, a full-on cordyceps-style human apocalypse is highly unlikely. Our internal body temperature is way too high for most fungi. It's a great defense. Plus, we have incredibly complex immune systems. But, and this is a really big but, the concern is all about adaptation. As our planet gets warmer, fungi are being forced to adapt to higher temperatures. And we are already seeing the rise of really dangerous, drug-resistant fungi like Candida auris, which is a huge threat in hospitals around the world.
And this chart right here really puts our ignorance into perspective. We've identified about 200,000 species of fungi. Out of those, only about 200 are known to be a problem for humans. But look at that last bar. Scientists estimate there could be 2 to 3 million more species out there that we know absolutely nothing about. The fungal kingdom is a massive blind spot for science.
So, while the zombie ant fungus might not be coming for us directly, it's a pretty stark reminder of the complex and sometimes terrifying power of the fungal kingdom. As our world changes, it forces all life on it to adapt, and that leaves us with a pretty heavy question. What else is out there waiting in the wings?